Yep.
Hello, everyone. Just give us a few minutes, everyone, to join. We'll start in 2 minutes. Okay, well, I might start. Welcome, everyone. Good afternoon. We're pleased to introduce the first webinar for Australian Health Design Council for 2026. We have 140 of members registered for this event, so I think some of them will trickle through now. And this is great to see that this topic has, really high interest. I like to start by acknowledging the traditional custodians of the land in which we meet, and pay my respects to their elders, past, present, and emerging. I'd also like to acknowledge our sponsors, our partners for this event, and our continuing foundation partners, Architectus, Putnam, BVN, Durofus, Enware, HPA, Polyfloor, Wilhelm, HDR, and Draeger, Hypack, Lucid Consulting, Mott MacDonald, Ceres, and Studio SDH. Before I start the session, I'd like to just cover some housekeeping. This webinar is being recorded, and this will be published on our website for members. The Q&A will be recorded, but not the any discussions that happen after the formal sessions. After we finish the Q&A, we will leave the webinar open for discussion for a little while, 15 minutes or so, if you want to stay back and ask follow-up questions. So we can always have that in an informal setting. And during this session, we'll have the Q&A button available. So put your questions in as you go, and that will help us organize that. CPDs are also being offered for this event, so please refer to our website for details on that. We're going to do two presentations back to back, so it's important that we get your questions as we go. Anyway, let's start just talking about this topic. Today we're looking at how healthcare design is responding to two major pressures: sustainability and a growing urban density. Our colleagues at HDR will share two short presentations tackling this from different angles. The first one explores how high-rise hospitals and vertical design can improve efficiency, flexibility, and user experience in dense cities. And then the second presentation will look at how mass timber can be used in clinical settings, including international case studies and research into embodied carbon and potential well-being effects. Okay, so let's go into our first one. Seems like it's delayed. Here we go. Our speakers for the first session for vertical healing, redefining healthcare through high-rise and hospital design. Connor Larkins is an Australian health principal at HDR, bringing over 18 years' experience across health science, education, and research sectors. She takes a human-centered approach to the design of healthcare environments and is passionate about the impact of good design on hospitals, the patients, staff, and visitors who use them, and the communities they serve. Brian Kowalczyk is the Global Design Director at HDR. He has elevated design excellence throughout HDR's culture, paying special attention to the humanistic, organizational, and business aspects of design. With over 35 years' experience in large-scale technologically complex projects, Brian shapes architecture to enhance organizational missions, increase efficiencies, and create inspiring spaces. I'll hand it over now to Connor.
Fantastic. Thank you, Alison. Um, so I would also like to start by paying my respects to the Wurundjeri, Woi, Wurrung and Bunurong people of the Eastern Kulin Nation from where I'm joining today, and also extend that to elders past, present and emerging. So thank you, everyone. So Alison's already covered this off. I'm Connor Larkins, Health Principal at HDR, and Brian Kowalczyk, our Global Design Director, is joining me, I think, from New York, Brian, where it's sometime after midnight. So thank you for staying up late, and thank you all for joining this at a slightly earlier time than I think we would ordinarily have one of these. I think Alison's kind of touched on this, but really the slides that we've put together around high-rise hospital design are looking at, I guess, the different ways we would approach the design of these high-rise facilities compared to, I guess, what you might call a more traditional horizontal building. So we have, I guess, a raft of these projects, extra large and high-rise buildings that we could, I guess, sort of look to discuss today. We've picked 4 in particular, which we think give a really good cross-section of the different philosophies and strategies that we use when we are designing these buildings. So those 4 projects are the Clifton Centre, the Shirley Ryan Ability Lab, the Wexner Medical Centre, and the MD Anderson Cancer Centre. So I'll pass over to Brian now.
Yeah, thank you, Connor. I appreciate that. And it is not only late here, but it's actually cold here as well. So have a whole different kind of philosophy. I was thinking also about the 2 titles, Mass Timber and high-rise hospitals, thinking about how wonderful it will be to do a high-rise mass timber. Maybe next year we'll get to that point. I'm showing some sketches here. As Connor mentioned, I'm design director of the company. I tried to put together 8 or 10 kind of characteristics that set apart a high-rise hospital from a more traditional hospital. And you see this first sketch here speaks about some of those issues. The first is a very consistent floor plate. Having a floor plate that fits all modalities, fits all the activities in a building is very indicative of a high-rise hospital. A more traditional hospital tends to have a podium, has patient room wings and so on. It's quite different in terms of being able to have the flexibility of having different size floor plates to accommodate that. Next point deals with the mechanical systems associated with that. A more traditional approach generally has a mid-level mechanical that serves interventional below and has a rooftop plant on top that basically serves each one of those very bespoke special pieces. In a high-rise hospital, you tend to have kind of layers of mechanical spaces. This does a couple things. One, it needs to be the same size as the floor plates. And number 2 is it starts to take away floor spaces. You have vertical risers going both up and down. It's quite a different way to look at a mechanical system and a different way of distributing mechanical on each floor plate. Third issue has to do with just plain circulation. The vertical high-rise circulation becomes the driver for most everything you do in a high-rise hospital. Most of the time, horizontal circulation drives a traditional hospital, and it's quite different in terms of the spatial aspect of that as well. Next, and the experience. Generally, the floor plates for a high-rise hospital tend to be 3 to 5% larger in area. This is due to a couple things. One I mentioned is the number of lifts that are required on a floor plate. And the second is the floor plates tend to be smaller. And those 2 things counteract the efficiency factor. So trying to gain an efficiency is more about having repetition on each floor plate. Next slide. The car park becomes an issue as well. I'll be showing you 3 different options today. Sometimes they're in the basement. That creates kind of some difficulty in terms of structural systems. Sometimes they're at a mid-level that separates the lobby space from the upper floor plans above and creates some interesting logistical challenges that are faced there. And sometimes in very dense urban centers, there are linkages that tend to have multiple levels on ground 1 and 2 to kind of bring people into the building. So quite different in terms of then how the lobby space works. Left-hand diagram here shows the idea of a more traditional lobby from a basement that requires you to change lifts to rise up the building. And then the sky lobby idea being able to have patients and visitors kind of enter the ground floor and be able to go to a sky lobby some level above. And then the idea of a more kind of an upper lobby, lower lobby approach. All these are indicative of high-rise solutions. Next slide. And also looking at the structural grids, obviously you you always try to line up structural grids, but in this case, it's imperative. And having everything from interventional kind of exam rooms, outpatient kind of operating rooms and whatnot that line up with those bed floors and diagnostics becomes somewhat tricky in laying out a building. Some of the issues too is you tend to have multiple floors of one department. For example, you might have 3 or 4 floors of operating rooms. How do you then connect those together for synergies between them or different modalities that want to be connected together? So creating some sort of kind of 2 or 3 story vertical connectors becomes imperative to have those connections you want to have in a hospital. So I'm going to walk you through. It's all yours, Connor. Go ahead.
Oh, I'll just do the intro. I'll just quickly. So the first case study that we're looking at is the Clifton Centre for Medical Breakthroughs. So this one is 17 stories. So, maybe at the lower end of what we would classify as high rise. This is at the University of Pennsylvania in Philadelphia. It's obviously quite a large footprint building, but when you look at the campus that it's sitting on, it's very much a brownfield campus. It's a very constrained site. You can see that it's surrounded by, lots of context, including, significant historical and heritage buildings, and also has a requirement to make critical public, clinical, logistic links into the rest of the campus. So I'll pass back to you, Brian, to talk to that in more detail.
Yeah, if you move ahead, the site plan here is quite indicative of what a traditional hospital may be. This is a ground floor plan here. And something Connor mentioned is the multiple pressures that drive into this ground floor. Having the emergency department right in this location right here, having the ambulance blue lights in that location becomes have a major kind of force. Having the lobby space that actually in the drop off in that location right there takes up a lot of the area. And then looking at the 2 lift cores, I mean, something that's indicative of a high-rise hospital tends to be, in this case, these 2 vertical lift cores that happen in that location. The drivers here, though, are getting down to the car park below, right here, having logistics coming in, going to the lower level of a basement, then having a kind of a rail line that actually has a stop right here, having entry and people that have to walk by this building. So there's a number of forces that drive both the shape and organization of this ground floor. And the pressures there drive both logistics down below, parking down below, and actually some functions that want to be in the ground floor up above. Next slide starts to show the section of that building. You see how the car park works, kind of down below the eastern side of the building is shown down below the lower 4 or 5 stories right there. The ED department, and the yellow represents public space. Now here we only had 2 mechanical floors that filter 12 floors in between. The blue areas above are patient floors, 72 beds per floor, and then 3 levels of interventional procedural rooms, operating rooms. At the ends of these, you'll see in the plan right here, we have vertical connectivity. So the doctors and nurses who are kind of off on a break and midway through an operation can actually share and kind of have a respite space at the edge of the building. Quite important to what Penn's philosophy is. Next slide. This kind of shows the tightness of this campus and kind of the ways in and out that I mentioned before. That is probably one of the most important drivers when you get a smaller footprint and how you navigate all those horizontal circulations from the outside, immediate one place on the inside of the building. Next slide. This shows a couple of the different floor plates of the parking kind of access point, kind of the area from the rail coming in, and really the connection between 3 major hospitals tied together. In fact, that becomes part of the Penn campus that allows us to actually function as one major campus, even though it's a separate building, both from a security standpoint as well as from a clinical standpoint. And then showing how that works from the public realm, looking at bringing kind of outsiders, not through the hospital, but past the hospital, making sure that, in fact, the fabric and the urban realm remains constant and positive. Next slide. Typical floor plate. This is actually a very, very dense floor plate, 72 beds. And something that the client wanted to have was have the ability of having kind of 2 24-bed layouts for that health area, being able to have something that had actually 3 groups of 12, of 24, 24, and 24, and being able to have the flexibility being able to have that change over time and kind of adapt over time. Two major clinical cores shown here and here that actually brings everything up and down the building, and it allows this kind of offstage corridor to snake through the building, which keeps the public corridor on the outside working, kind of, I know, crossovers between how that works. So that's a very tight floor plate. The ends of the building here as well have a vertical connection between floors to connect those modalities vertically in the building, as well as being able to have the flexibility on each floor plate for those patient rooms. A typical patient room here, a lot of kind of an outside kind of bathroom area. In this case, having the ability of having a family space on the outer edge of the building, high technology, being able to have kind of doctor visits and whatnot in that room with a foot wall, and being able to make this kind of work in a way that both gets the connection between where we're standing here, looking nursing, looking at the high acuity spaces, and being able to have the quality of the outside, letting light in and having respite for the family. This shows the surgical area I mentioned before, kind of two clusters of ORs on the outer edges, and recovery kind of in the center. Straightforward kind of layout there, and being able to have these vertical core connections, break areas on each floor, rising up and down, and having kind of the exterior corridor that's free, okay, to be able to circulate around the building to get from one side to the other in terms of surgical connectivity. Next, kind of a photograph showing the drop-off, kind of the front door and those urban connections you start to make, and then looking at kind of the reception desk, the ambulatory reception desk, and the public space for gathering and for communication, auditorium, and that sort of function in the front of the building. In the cafes. So the second floor actually contains all of these public functions that connect to the rest of the campus. So many of the functions you might have on a lower floor are moved up to floors 2 and 3 at a vertical campus to be able to connect those to other buildings on the sites surrounding.
So the second, sorry, Brian. The second project that we are going to share is the Shirley Ryan Ability Lab. This one is in Chicago. Whilst it is kind of part of a medical precinct, it's essentially a standalone building in the downtown area of Chicago. This one is 27 stories in height, and you can see from this kind of aerial image that it effectively is occupying a similar footprint to, an office building, and essentially surrounded by office buildings as well in that really urban setting.
Yeah, in this case, it's quite different than the Penn project. I wanted to show something quite different. There's basically a car park that's built on levels 2 through 8. So the car parking actually occurs in this location. So there's a lobby down below, a sky lobby above, support spaces for the rehabilitation hospital there, and all the patient rooms and the research as part of this are at the top. That's the patient rooms and research. That was done to get the best views and kind of the best environment for the inhabitants of the building. In fact, in a rehab hospital, they might be there between 30 and 45 days. And being able to have that feel almost like a hotel or someplace to kind of go and rest and rehabilitate at the same time having research taking place to actually make their lives better. So the idea about being able to have a kind of a wonderful environment and great place to be is part of the focus. So quite different than the Penn building and blocking and stacking. It's part of the campus, a Northwestern campus, as well as kind of the area of Chicago that's very dense to an office environment, as Connor mentioned. The ground floor plan has precious space to kind of give up to different areas. The car parking access, the drop off right here, logistics from the backside and so on. I think we would blow up of that plan next, I think. Connor? This is the lobby from the ground floor plan in the corner of the drop off, but then it rises to the sky lobby you see here on the floor above. So the idea is to make a vertical connection kind of aesthetically as part of the building. Next slide. And being able to have that be kind of a clear kind of order that goes from that ground floor for the public, comes off here from the car park and then rises up these lifts to get to the sky lobby above. Once you get to that sky lobby, you kind of, on the right-hand side, you get to see what that view is out to Lake Michigan and be able to have that kind of be part of the brand for Shirley Ryan. Next slide. This is a sky lobby level. Two important pieces here. One is to be able to have an outdoor garden space, and that's used for both patient access and patient be able to get outside when you rehab function, and all the public functions that actually occur kind of in the Shirley Ryan facility. Something I mentioned early on was about the number of lifts, and I think that's quite extensive in terms of being able to see how these buildings work. The arrival elevators, for example, happen here, coming from the car park to this floor. Once the public can get there, they can then go up here to the upper floor plans in B. At the same time, you need the clinical lifts, and the clinical lifts are in C. And you see the kind of area that starts to take up and the logistics that kind of works in a building like this and security aspects. So these precious small floor plates become very much compacted with a lot of the public amenities that happen on the outside of this building, and being able to have that be more of a kind of a staging area to get to and fro the building. Next slide. This is an interesting part of this facility that, in fact, the 8 upper floors where patient floors are have different modalities in terms of the research and the care taking place. Each pairs of floors get connected. So the rehab gymnasium here in terms of the care taking place and when you're learning how to kind of walk again, if you're learning how to navigate stairs or kind of move around the building, these double height spaces become both connections for staff as well as patients between one another, and being able to have kind of the quality environment taking care of a view of the outside space. So really trying to kind of increase that double height connection between floors. Next slide. This shows public area I mentioned before. Next slide. Move ahead if you could. It just starts to look at kind of how that space starts to work, and I can kind of go through these pretty quickly, Connor, if you would. Looking at just kind of how a typical floor plate works here, the same sort of thing. 36 beds on the outside, research labs located in the center of those beds, and that double height gym, as I mentioned over here. And all support spaces wrap the core. Next slide. The research space is quite important to Shirley Ryan in terms of being able to not only have different therapies and whatnot, but the next slide shows about being able to actually have them be able to kind of research spaces to have better ways to be able to navigate if you lose a limb, or being able to kind of challenge in some of your activities. You see that activity, you see that research, and you feel kind of inspired by that. The Wexner Medical Center is a large building in Columbus, Ohio. Go to the next slide. It's a very, very tight site on a very, very large Ohio State University campus. The new building is actually an addition to an existing kind of series of hospitals that occur. So the building here was a high rise that wanted to connect into a high rise building and be able to have new kind of high acuity patient rooms to connect to that existing cancer center called the James. Next slide. A car park was put next to the site right here, and that car park actually is made to be able to expand 8 stories higher for a medical office building. Next slide. The section here is quite interesting in being able to think about the idea of this being a high acuity center for the entire state of Ohio. Maternity at the upper floors, and a series of lobby spaces actually happen on the lower 3 floors connecting into this building, from logistics, as well as kind of main entrance tying to James Hospital, and a second story entrance from the car park. Next slide. A 2-story interventional platform. Part of the issue here too was to be able to have Ohio State give back land. The green space here is kind of a developed parkway along the waterway that was given back. It used to be a car park, actually. It was given back as part of the exchange for property with the city to make this hospital work. Next slide. The logistics here is handled in an interesting way. Logistics happen on the back of the campus right here, kind of feeding into the existing James building. And there's a loading dock door coming in here, the loading area, and receiving is in the sliver right here. And the ED access actually happens in a really interesting way here, coming in this location right here. So it's a very, much like Penn, a very, very tight urban campus, but being able to navigate that by having multiple levels of logistics and facility management. Next slide. And the car park here was kind of planned initially for below the building. And I think the study of being able to have a medical office building and a parking garage was less expensive and also more efficient in terms of being able to have the high-rise hospital work. Those trade-offs happen all the time. Next slide. And again, it's tied to a network of existing hospitals that kind of connecting together on multiple levels in those lower 3 floors. I think that's somewhat indicative of doing a high-rise hospital. You end up having 2 or 3 lower level floors to act as the public kind of interface between existing buildings and the ground plane. Next floor. This slide. The diagram here actually has 3 cores. One is the public core that basically kind of happens along the center to be able to kind of have views to the city and views to the country, and 2 30-bed units on either side that has 2 clinical cores shown right there, serving into James and serving the 2 wings. Next slide shows that plan and how that works in a very organized way. Something interesting here too, being able to have, much like office buildings do, 2 public lifts, one between 1 and 15 and one between 15 and 27. Having them staggered to be able to gain space and efficiency that way. Next slide. Next slide would be fine. These gestation rooms, the toilet area on the inside to get a kind of a better sense of the outdoors. Next slide. And being able to have the same sort of technology that we had at Penn. And this is a public entrance area at either end of the building. Next slide. So the last project I'll probably get to will be talking about the MD Anderson facility, which is now kind of in the middle of design development. It's on their campus in Houston, Texas, about kind of 150,000 square meters. It's mostly an outpatient building, but has 192 one-day beds. And the idea there is to kind of interface between an outpatient kind of ambulatory building and an inpatient building to serve the needs of people with cancer. This is 100% cancer, so MD Anderson is a leader in. And the goal of this project is called Let the Sunshine In. As an idea, next slide, is to look at this campus, which is very, very dense, and look at the healing power of nature. If you go to the next slide, you can kind of see the one green area in their campus left over. And the idea here was they wanted to put the building on the entire site. And our thought was to maybe put a kind of a taller building and keep this green in a very, very important way. Next slide. And being able to actually salvage some of the beauty that kind of exists on their campus in Houston, Texas. Next slide. Being able to have the idea of this lobby connecting to nature, keeping the park in the middle, and not having you confronted by a black wall get behind them, but by something that actually spans that landscape between inside and outside. Realizing that landform and landscape can actually heal. Next slide. This kind of shows a rendering of what that might feel like. Next slide, keeping those trees. And something that's kind of interesting here, next slide, is looking at the sense of being able to have a flexible, modular, expandable environment. So here we looked at that building having 3 modules per floor, and they would be anything from a clinic to a 12-bed kind of unit, to being able to have it be a kind of radiology space, an OR room, and so on. So thinking about having these modular approaches means we can do this building as a core and shell and look at putting anything anywhere. That's part of what MD Anderson wanted to achieve and being able to handle this. So having this be a bay module for kind of infusion bays, or having clinic layouts, or having patient rooms, having that modular approach is kind of the goal behind the entire layout of this building. Knowing that health will change over time, and being able to have that flexibility gives them flexibility for the next 50 years. So thinking about that as an idea, having the ability here of adding 1/4 module on this building, having radiation oncology pulled out in that egg-shaped space below above grade, taking advantage of connection to the landform as part of the idea. Next slide. And then being able to have this stack in a way, it's showing a stacking there, but the idea of these kind of interplaced mechanical spaces allow you to have that flexibility both horizontally with the plan, but also vertically with your mechanical at the same time. Okay. Now I did it. Now I can't erase my stuff. You're going to have to do that, Donna. There it goes. Good.
Sorry.
Okay, the cores.
there.
Yeah, the cores. If you look at the cores, go to the next slide. It's kind of interesting here. We did the next slide shows the plan of that. That part of the goal here, kind of early on, was to look at this. What makes this flexible is a number of vertical connectivity that happens between the building. So believe it or not, that was kind of a very important aspect, not only of cost, but of movement systems throughout the campus. Next slide. The lobby floor is what I mentioned, just being able to have that see-through kind of space between the garden, the pool beyond, kind of the water feature and the landscape beyond, and being able to have that flexible kind of environment beyond that shows right here with the clinic floor shown here, layered. These areas in the back that are shown in this rendering, are shown in the rendering, happen at different locations in the building, and they're able to be moved around that facade. The idea there is over time, there'll be changes in terms of the clinic sizes, the cancers they're dealing with. And part of MD Anderson's culture is to be able to have those connections on the staff side of the building to really kind of engage modality connections between nurses, doctors, and staff to really focus the best care on the patients they can have. And that becomes kind of an emblem and a symbol towards their existing campus. It shows a section of the building, interventional down beneath. This is those green pods. And just thinking about where we're taking that, if you go through the next series of slides, we're taking that into kind of this vertical space that becomes break space and kind of space to allow the staff to both get up and down, but also be able to have that break space and conference area at the edge of the building. So move through this, Connor. I know we're a little bit behind here and just trying to kind of look at 4 different ways of being able to look at these sort of diagrammatic approaches towards high-rise design. So it's a little bit different than doing a regular hospital, and I think those differences can be advantages if you think about being able to vertically connect better. And some disadvantages are being able to have that extra efficiency you need to add into the building. So thank you. I appreciate it.
Thank you.
Thanks, guys. Is that the last slide?
That
Right
is.
Yep, that's it.
Thanks, Alison. Thanks, Brian.
Thank you.
Great. I'll just quickly reshare. Thanks, Connor and Brian. We'll now move on to our next presentation. Quickly share. Oh dear.
Oh dear.
Let me try that again. Okay, so healing spaces, the transformative potential of mass timber in healthcare design. I'll introduce our speakers for this one. With more than 20 years experience in architecture, master planning, and urban design, Alison Potter is a design principal at HDR committed to sustainable, future-focused design. Alison's work is grounded in health and institutional projects shaped by social and environmental design principles. A Living Future accredited professional, Alison advocates for low-carbon, ecologically integrated design and contributes to national sustainability and design review. Jeff Mosher is an associate health principal at HDR, a LEED and EDAC accredited professional, and a certified passive house designer with 18 years of industry experience, primarily focused on the design and construction of high-performance healthcare facilities. Jeff's recent experience with project delivery on some of Ontario's largest and greenest healthcare infrastructure projects have given him unique insight into the best practices in sustainable healthcare design, emerging trends, and what will it take to make net zero carbon healthcare the norm and not the exception. I will hand it back to Connor to reshare, I think, or Alison.
I will share from my side. Thank you. Okay, just checking everyone can see that.
Just need to make it full screen.
Yep,
Yep.
good.
Great. A little bit of a lag there. Excellent. Thank you. So I'd also like to acknowledge the traditional custodians of the land that I'm joining from today, the Wurundjeri, Woiwurrung and Bunurong people of the East Kulin Nation, and pay my respects to elders past, present, and really recognise that there is so much to learn, and I'm very grateful to be able to continue to learn from its deep histories, cultures, and knowledge, and bring that into our design thinking every day. So thank you. So we've had the introduction. So I'm based here in our Melbourne studio, and joined with my colleague Jeff, who's on the very other side of the world, equally in a awkward time zone, from in Ottawa in Canada. So kind of interesting change of weather and seasons, but it's a really interesting topic, I think, for us to, I guess, learn from our counterparts, and learn from kind of extreme climates. But it's really foundationally asking this question. So what if the hospital structure itself could reduce carbon, improve wellbeing, and still meet infection control and fire safety expectations? So this is really foundation of what we'd like to explore in this presentation. And really, we wanted to really talk about the broader aspects of the benefits of mass timber as well. So biophilia, obviously there's a strong relationship around patient recovery and well-being of staff and visitors. We really wanted to kind of, I guess, talk about what are some of those kind of current or traditional barriers to design? So working through some of those compliance and infection control standards and fire safety regulation topics in a lived example. We wanted to as well touch on the kind of, obviously there's the environmental advantages of mass timber, but just touching on that within the context of also the Australian market, through, again, the kind of shared stories that we have with our global projects. And there is, also a connection into community, how this is also about community engagement. Again, that's really quite an interesting and connected part when we're talking about mass timber. There is often a story there around community. And really it is about moving forward. And I think Brian sort of said it really interestingly earlier around, well, how can we almost upscale our use of mass timber and looking at in more kind of, I guess, innovative or progressive ways. So it's really about placing regenerative design, human-centered design at the core of everything we do. So just, what is mass timber? So when we're talking about mass timber today, we're really referring to kind of engineered timber. So systems that are designed to replace major structural elements of a building. So building elements that are typically used from steel, concrete. Really, that's what we're focusing on today. Very clearly, you need to know your acronyms when you're talking about mass timber. And, even glulam these days is being shortened to GLT in the market. I think really there has been a lot of momentum in the Australian market, particularly around CLT and glulam, GLT. And it's really interesting that we're starting to see this in a much more mainstream application within Australia. We're seeing it much more in mid-rise and high-rise projects. There is this sort of confidence growing to use that in more, I guess, non-standard, non-traditional ways, which is really exciting. And it's really, it has a massive advantage in that it can be prefabricated, that it can speed up construction timeframes. And, I think it really also starts to talk about the ability to kind of transform, I guess, our construction environments. And Jeff will talk about that in a moment. So, I think, again, it's always kind of this challenge. How do we do it in Australia? I think it is worth acknowledging, that Australia has a growing market. It's had local investment and government investment into growing our domestic capacity within the Australian market. So it's really exciting. We obviously still tap into our global kind of supply chain as well. So it's really interesting that, you know, again, demand is really stripping supply at the moment within the local market. So we will continue to have European and global supply chains continue to support this for a while yet, I think. So, you know, again, there's obviously a big advantage in using mass timber from its ability to store carbon and reduce upfront carbon emissions. So, you know, when it is sourced sustainably, it can serve as a long-term carbon sink. It can support forest regeneration and really help us reduce our reliance on carbon-intensive materials. So, obviously, that's it's a very wide kind of consideration, I guess, of understanding where does our timber come from. I wanted to kind of share actually a little example. This is a project I worked on many, many years ago when I was at Foster and Partners. But what was really interesting about this project for me was that it really taught me a lot around designing with timber, and also just understanding and working with suppliers and understanding how mass timber is produced, how it can be really connected in with its ecosystem. So this particular example is for a project that was in Abu Dhabi. The timber was sourced from a forest and a manufacturer in France. And what you see there on the left is really a completely circular loop in terms of production. So the timber was sourced from the forest next door. It was CNC'd, and any waste cutting from the CNC actually powered the plant itself. So it went into a kind of CHP facility. So that it was incredibly carbon neutral in its kind of processes. So the carbon was really within the transport itself to site. But it was quite an interesting process to understand the power of, I guess, timber to really minimise its impact. And I thought I'd just share these examples as well, just to kind of, you know, in a way, a little bit to reassure myself too around mass timber's, I guess, uptake within the Australian market. And, you know, this kind of idea that, you know, we need to think, you know, broadly about how we use mass timber, and thinking of hybrid structures as well starts to, I guess, free up how we think about the ability to integrate mass timber into a range of different types of projects, and work around some of those regulatory constraints that we have. So lastly, I wanted to kind of touch on biophilic design. I think really there's huge amounts of research that, particularly within, you know, kind of a workplace environment around the benefit of biophilic design and the kind of impact that has to reduce stress, to kind of reduce blood pressure, and to lower cortisol, to kind of improve and elevate people's frames of mind. That has also been applied in healthcare projects for a very long time now. So some of those that research and the evidence around the benefit to have very positive impacts on clinical environments in terms of patient recovery, in terms of mental health and well-being. So we're really starting to see the kind of evidence emerging through, you know, timber being used in this way for a long time now. So I think it just is a bit of a reminder that I think when we're talking about mass timber, there's many ways that mass timber is being thought about now within our project environment. It goes much more beyond just the aesthetic choice. You know, it really is around how it's meaningfully able to influence psychological and physiological well-being, but also how it has obviously other benefits to its sustainable design as well. So with that, I'll hand over to Jeff to tell you the story of one of our very own projects.
Thank you, Alison. Excuse me. Good afternoon, everyone. So yeah, we're going to share a case study from the other side of the world, in Canada, the Prince Edward County Memorial Hospital, which has the honor of being the first unencapsulated all mass timber hospital in North America. You can go to the next slide, Allison. So just to give you some context as to where this is, you may have heard of Prince Edward Island, and that is actually not where it is. It's in Prince Edward County, which is in Ontario. It's a small community on Lake Ontario, just north of the U.S. border. You can go to the next slide. So it's in the little town of Picton, Ontario, which is a community of about 5,000, but it does serve a much larger region, but very cute little area on the water. You keep going. And it's run by a health authority called Quinte Health. And so health authorities in Ontario and Canada are similar to what you would call local health districts in New South Wales. So Quinte Health runs 4 different community hospitals in Ontario, and it spans an area of about 100 kilometers. But within that region, there's only 500,000 people. So it's geographically large, but demographically small as a region. And as a bit of a comparison, that looks like this in Greater Sydney, which I learned recently. There is a Picton in Greater Sydney. So, funny coincidence there, but that gives you a sense of scale as to how large of an area Quinte Health covers with their catchment. So who was this project for, and who was doing this crazy thing? So Quinte Health was actually the amalgamation of 4 different hospitals. And this project almost didn't happen. There was, during this amalgamation period, they were going to close and consolidate to a central hospital, but the community really spoke up. They were proud of their hospital. It was important to them, and they really got behind it, which was part of the success story here. So here we are today building this hospital in Picton. So what is Picton? Well, the New York Times had a bit of a cheeky take that it's a little island for hipsters, but there's a little bit more to it than that. If you keep going, it is wine country. It's very rustic. The wine is rubbish, but the vibes are fantastic. But it has a long and storied material history of using wood to build. This is the first documented structure in the county. Just up the street, this is called the Crystal Palace, another wooden building very prominent in the community, dating back. If you click again, there's a little animation, I think. We have done fundraisers in this building for this hospital, so still standing today. Next slide. The typology is very agrarian in the region. There's a long history of post and pole barn buildings. This is an old picture of that happening many, many years ago. And if you click again, we've done fundraisers in a barn for this project. Barns are very a prominent theme in this region. So the vernacular is very much based on mass timber in this area. Okay, so what are we building here? So basically, it's a small community hospital, and the plan is to build a new hospital beside the existing on the same site, knock down the existing, and then build a parking lot where the existing was. Simplified story there. Small facility, about 10,000 square meters, 2 stories. So the opposite of what Brian and Connor were sharing with you earlier. And that size is part of what allowed us to do this, that size and scale. But it's about 24 bed inpatient unit, an emergency department. There's some minor procedures like endoscopy, that sort of thing. And then on the upper level, if you click again, Allison, there's satellite dialysis, some admin areas, and a large mechanical penthouse. And mass timber is kind of the headline here, but this is actually a deeply green hospital. It includes a whole host of sustainability features. It is actually modeled to be one of the most energy efficient hospitals in Canada on an EUI basis. So not just because it's small, but even compared to its peers. I won't read through all of these, but we did look at all the facets of sustainability on this project. So why did we do this? Allison alluded to some of this. Why mass timber specifically? A few different reasons. So you can see it's really all mass timber, even the penthouse. We do have some concrete shear walls and slabs on grade, but all of the superstructure is effectively done in mass timber. And if you keep clicking there. So one of the big reasons was the embodied carbon aspect. And this is kind of the way that you would do an energy model more than a carbon model. But if you look at the avoided embodied carbon by using mass timber instead of something like steel, it's almost 10 million kilograms of CO2 avoided, which is very significant. If you click again. And then there's the biogenic carbon aspect. So as Allison mentioned, mass timber is a carbon sequestering material. So if it comes from an appropriately managed forest and you have an end of use decommissioning plan in place, you can actually deduct that sequestered carbon from the carbon emitting materials on the project. Keep going. There's also a certain beauty and a warmth and a tactility to the material, those biophilic benefits that Allison was talking about, which we really wanted to highlight here. And we felt that really added to the patient and staff experience. And you can see here, there are lots of precedents, like in the lower right, where in common areas, mass timber elements have been used, but we're bringing it into the patient room, into the inpatient unit, nurse station areas, and really trying to expose that material to really benefit that patient and staff experience with those biophilic benefits. There are some challenges to that. And so one of the big ones, of course, is infection control. We worked with a man named Dr. Dick Zoutman, who's a bit of an expert in infection control in this area. And he started with a story about a cutting board. He said, what kind of cutting board do you have at home? Is it plastic or is it wood? And some people were split. And he said, I use wood. And if you click one more time, I use wood because wood wicks moisture away from the surface, whereas those cuts in the plastic, they're going to harbor moisture and allow for bacteria to grow. So that was a really powerful analogy that kind of set the tone for how infection control might be thought of here. If you go to the next slide, though, we've all seen a cutting board that looks like this. Hopefully you're not using it, but you've probably seen it. So what's happening here? This kind of contradicts what Dr. Zoutman told us, right? So the secret is in the moisture content of that wood. If you stay below 19%, you keep it dry, it will not grow mold or fungal growth. You get above 28% and you're really in the danger zone. So keeping it dry actually inhibits mold growth. The second big thing is fire safety. So the way we deal with fire safety, a few different ways, but one of the main ways is to just increase the mass of the structure itself. So oversizing members to allow for a burn rate and a char layer to develop where there's enough cold wood left over that the building won't collapse within its fire resistance rating timeline. The other thing we did on this project that was a little bit creative is we actually split it into 3 buildings. So the building code in Ontario allows for combustible construction under a certain floor area, so long as it's sprinklered. So we snaked a firewall through this building, creating 3 separate buildings. So 3 main entrances, 3 fire department connections, 3 fire alarm enunciator panels, so on and so forth. Each of these individual buildings is below that allowable limit, which is how we were able to do this completely unencapsulated. We didn't need to wrap it in drywall. And then if you're going to all the trouble of building with unencapsulated mass timber, you want to show it off, right? So we took an approach where we tried to create these kind of zones where we could conceal services. It's not like, some mass timber buildings you've seen where you have exposed spiral ductwork everywhere. That becomes a dust shelf. We can't do that. So, we've concentrated services in our penthouse. We've created these kind of corridors for infrastructure, and then some smaller little architectural details to conceal services in other areas. And that really allows us to expose the mass timber in those high impact areas. There have been some challenges on the project. I mean, I think we've had some great successes, certainly. But there are some things that, if you want to try this at home, you may want to watch out for. So one of the things we learned is that the way that the CLT is fabricated, you really want to shop core it. You can field core it, but it's messy, right? As the drill bit punches through the other side, it splinters, it doesn't look great. So the traditional coordination model breaks down a little bit in that trades like sprinkler contractors who submit their installation drawings much later in the process, they really need to get their stuff in soon before the mass timber is fabricated early on in the process. The BIM level of detail, 5 trillion isn't an actual LOD, but the higher the better, because the more of these penetrations you can get dialed in during design, the better off you're going to be. This is actually our penthouse on the project, which is, we were calling it the mechanical cathedral because it's this incredible space. But this goes to show that, mass timber can be used for these high bay, large span spaces. And it's a shame that this is going to be rammed full of ductwork and no one's really going to see it. But we did commit all into using mass timber for all the spaces on this project. Water is a big challenge. As I mentioned, we do need to try to keep this material dry. So there's a few different things happening in this picture. One is, obviously we have some puddles of water on the floor. There's active drying happening with the fans. There's also people were using leaf blowers and shop vacs to try to get any surface water off. These steel upstands, essentially they keep the glulam columns up off the floor so that during use, if there's floods or excessive mopping or these sort of things, the columns aren't going to sustain any water damage. One of the other things you're seeing here is these covers on the splines. There's these mending plates that go between CLT panels. And the idea there is because we're exposed below, we don't want any of this water on top to drip through those cracks and stain the CLT below. So that's really to preserve the aesthetic of the wood. It can get wet, it just needs to dry, but until it dries, we definitely don't want it dripping below. So water is probably the biggest challenge on this type of construction. Especially in the winter. We've been building through some extreme conditions. It's been a difficult winter here in Ontario. You can see where we're snow blowing the roof, which is a very Canadian way of dealing with moisture management.
In talking about mass timber within the Australian context, I think I can't help but go, well, Jeff can get this done in snow, then, surely we can do that here. And I think hopefully everyone's learnt a little bit and hopefully been inspired by, the potential of mass timber. And I, for one, am pretty excited about, the opportunities to sort of really explore this and push this further within our Australian context. So thank you, Jeff, and thank you, everyone. Thanks.
Thank you.
Great. Lots of claps. Sorry you can't hear them. You guys want to turn your cameras on and I will transition into Q&A mode. If you haven't got a question ready yet, now's the time to type it in while I start. And then, we can always follow up with answers. Brian, I can see, is already answering questions in the background. So that's good. So I'm just gonna start with one, which I don't know if it's for Connor and Brian. I'm not sure if I'm being cynical or it's something you've already thought of, which I'm sure you have. In your last project, you had these pop-out pods. And Brian, you mentioned, plug and play sort of could be moved around in the future. I guess you're saying could be designed to remove and replace. Is that a realistic goal, or is it more about, I would say, a great goal would be planning flexibility, which is to say, as they finalize their planning, they might move around, but are they actually going to move around after they're built?
Great question, because I think when I showed this to the CEO of the hospital, he loved the idea. And in my mind, I was probably somewhat where you are, okay? The reality is we're in DDs. The idea with the contractor is to keep the construction cranes in place. There's much effort to move around big pieces of equipment later on, okay, during the change out and so on over the years. So in talking to the curtain walling manufacturer, it's
Mm.
realistic, and there's no reason we can't do that. It's going to be made prefabricated and brought in, and being able to kind of slot into the curtain walling system. It's a lot easier than I thought in terms of having them be self-structured. And I
Mm.
think the idea of flexibility, I guess that the point there is taking the idea of flexibility beyond just being able to kind of fit out of space, but flexibility in all aspects. So yes, I think it's realistic, and we're moving it ahead in that direction. I'm excited about it.
That's exciting.
Mm.
I'll send one over towards Alison and Jeff. Very keen on mass timber, definitely. We have quite a few on the books at the moment, not in healthcare, but we'll get there. Um, the one of them is around the carbon equation. Getting into the detail. Sorry, guys. You mentioned the char layer and the overscaling for that fire resistance. How did you find the carbon equation in terms of the different types of fireproofing options? Like, was there a comparison done between gyprock versus the extra timber versus another fireproofing material? And how did that kind of stack up for you guys when you did the equations?
That's an interesting question. We didn't actually do a life cycle analysis of that directly. Using larger timber members kind of came naturally because much of the facility is also designed for vertical expansion. On that, if you think back to that plan of the upper level, there's a lot of roof and not a lot of floor. So all those roofs are designed to be expanded on. So in sizing those members to allow for that vertical expansion, we were also able to get 2-hour fire ratings. So there wasn't really a need to evaluate, encapsulating with drywall or something as an alternative.
Okay. Peter's got a question. It's also about life cycle, but it kind of goes to vertical versus low rise. And that is around the business case between vertical and low rise. What is the context? What is the whole of life and staffing cost compared to the construction cost?
Yeah, I read Peter's question. I was going to start typing, but it would have taken me a while to answer the question. Every time, very few clients want to go high rise unless they are forced to by forces. Okay. MD Anderson wanted to keep something that they really wanted to have in their land. Okay. Ohio State had to go that high. They had to go that high. There were buildings in the way. So generally, high-rise buildings will cost more. I mean, based on the conveying systems and the 2 or 3% loss of efficiency, you gain though by being able to have closer travel distances. Actually, the time it takes to get from one place to the other is actually much quicker than in horizontal hospitals. So it's kind of interesting. If you do the cost analysis, it might be 2 or 3% more on the overall budget of a project, and many times the lower rise is the driver to actually have it be more cost effective, but they're always driven by necessity, I would say. But I find that in fact they can actually perform better even at a higher cost.
It's interesting, Brian, because there is a sort of tension there between mass timber and vertical, because we know there is a coefficiency around maximum height of mass timber before it becomes a hybrid structure. So you guys are pitting yourselves against each other, maybe on purpose. I don't know if you want to comment on that, but I'll go on to the next question. Alison, that's for you around compliance and stakeholder acceptance of mass timber in the Australian health context.
Yeah, and sorry. Just sorry, Connor and I are sitting next to each other and just get our audio sorted. Yeah, I mean, I think that's something that's interesting, right? Like, how can we actually start to challenge, and use that sort of, the evidence of our kind of global projects to kind of work with our stakeholders. I mean, I think in terms of, even as you were sort of touching on, like the hybrid timber, there's examples now, right? Like in the Australian market of that, and working around, those other challenges. I'm talking more like fire and other structural kind of regulations. So I think, I see there's an opportunity for us to actually be, being able to draw from these kind of international case studies regarding, in particular the infection control, and kind of might be able to speak to that.
Not sure what I've done to my sound. Hopefully you can hear me.
Alison, can you mute?
Hopefully you can hear me now. Maybe a question. Oh, sorry about that. Maybe a question for you, Jeff. Were there explicit conversations with user groups around particular cleaning products, and did you kind of have to prove to clinicians and infection control, people that they could clean the hospital with the same products, or did you have to agree to different operational approaches, or?
No, there were definitely lots of discussions on that. So some of it is a little bit perception based, right? So we had a question about, how are we going to scrub these CLT ceilings that are 14 feet in the air? We're going to need ladders to do that. And I kind of said, well, how do you scrub the acoustic ceiling tiles you currently have? He said, well, we don't, of course. Okay, but those are also porous. So why do you need to scrub the wood ceilings? And okay, so that one's perception, but some of it is very real, right? So anything that is within, let's say, the touch realm, we did seal. We had to apply a sealer to. That was what we got the buy-in for. So there's a penetrating sealer that goes in to protect it from moisture during transportation and construction. But then there's also a surface sealer that's being field applied, and it acts more like a paint than a stain, so it creates a film on the surface, which enhances the washability of those areas. So there are real concerns there certainly, but a good portion of it is perception as well.
And to the question about the height, we are working on a number of buildings that are 12 to 14 story kind of residential buildings, and I think the fact that we're doing the first mass timber hospital in North America, I'm optimistic that there will be ways to do that. And I think it simply is looking at the technology in different ways and having it be safe and having it be quicker to construct. I'm not sure if you want to comment on that, Jeff. I believe that we probably could go between 10 and 12 stories without big issues.
Yeah, and I think building codes are starting to adapt to allow that based on the research and evidence that's emerging. So I think we certainly will be seeing that in the future.
Staying on that for a minute, just a question around whether sustainability and decarbonization was embedded in the project brief from the outset, or was it something that was brought on as part of the design?
It was, yeah. So I mentioned, the community was a big driver behind this project. One of the big things that actually got Mass Timber off the ground was the donor community lined up behind it. Sustainability was really important to the people in this region. They got behind Mass Timber because of the decarbonization. They got behind geothermal energy and solar power, and the way the funding model works in Ontario is the government pays 90% and the local community pays 10%. This hospital raised their 10% faster than I've ever seen, and it was because the community really rallied behind these sustainability features, which was pretty cool to see.
Yeah, awesome. I might quickly switch back to the vertical realm. Brian, daylighting in depth into those footprints, I guess you're looking at a sort of 9-meter penetration if you're lucky. But I assume you have quite often floors in a hospital with large amounts of office or deep space to some degree, at least with more than 9 meters away, or at least with separated by walls or not glass.
Yeah, that's a great question. I mean, if you looked at all of those, I'll call them patient bed floors. That's where the focus is trying to get light penetrating into all those rooms. The support spaces in the middle of the hospital tend to not be those sort of areas. And I think, the MD Anderson, for example, it's really, really important to making that as thin as possible to have those modular formats. So that's probably the best case. American hospitals tend to be wider. My personal goal is to make them narrower and have daylighting for all, even the staff who are in the middle of the building. It is rarely a driver when it comes down to clinical space and that activity. I think it's something that I think we could all do a better job in.
Yeah, I mean, I think there's a huge range of workspaces within the hospital between people who are moving around a lot, and people who often get stuck in one space. I'm thinking pharmacy as an example, which I presume is in the deep space, as it often is.
Yeah, we designed a number of operating theaters that actually have windows as well. So
Yeah.
that's in Portugal actually. So I think I agree with you, and I think that we could be better as a designer kind of organization globally at
Mm,
looking at spaces where people generally want to have light shed out and actually allowing light in just for the quality of environment for, I see a surgeon who's operating on someone, right? Why not? And move in that direction.
okay. We've got two questions about vibration. So, managing vibration performance requirements in operating theaters and with imaging equipment.
Yeah,
Kim
but
says
very
that they've been told it can't support the vibration requirements.
Yeah, no, it's a good question. So on the Prince Edward County Hospital project, we put all of our diagnostic imaging equipment on the ground floor, slab on grade, rather than the upper level. So it was easy to get around that. But I don't know if anyone's familiar. There's a hospital in Wales. I forget the name. It was white architecture that was working on it, and
Yes,
they were trying to.
Velindra, they actually presented it at our conference last year.
Oh,
Yes.
did they? Okay, yeah. So you're somewhat familiar. So, Sophie over there will tell you she wanted to do all mass timber, but
Mm, yeah.
the span spacing to meet the vibration requirements was so tight that it like tripled
Mm,
the cost of the structure for those areas. So they ended up just going with concrete.
yeah.
In theory, it can be done, but it may not be the most economical way to do it. But if you can programmatically deal with that, that's the easy way around it.
Yeah, exactly. And I think for those who didn't see that presentation, that's exactly how Velindra approached the vibration requirement through uh, disaggregating the buildings into ones that were in concrete and ones which were in timber. Great. I might pause there because we are running out of time a little bit. And so we'll kind of, if you want to stay on and ask more questions after I've finished announcements, then please feel free to, and we can have a few more minutes of that because I'm sure there's other things to talk about. But before we do that, I'll just go through the little bits and pieces. So the QR code on your screen is to share your feedback on today's presentation. Tell us what you thought, and also, yeah, if you have CPDs, you can use that. If you want to get a CPD, you can use that QR code. Um, and just before I finish off, there's a few announcements. Um, yeah, so we've got two site visits coming up in March, which is really exciting. Amada Hospital is already available for tickets, so that is selling fast or yeah, filling up fast, I guess. That's for members, both of those site visits. And Children's Hospital at Westmead Stage 2 has been confirmed, so you will get an invite about that really, really soon. So be quick on your responses to get your registration in for that on the 13th of March. And exciting to be able to present as conference convener. We have a date for the conference this year, the 4th to the 6th of November. So that's Wednesday to Friday, and that's just the day after Melbourne Cup. And it will be in Brisbane. We'll be able to send you more details on that. The theme for this year is turning healthcare inside out. So we're looking at bold ideas to rethink how health connects with community, place, and everyday life. It is very much healthcare focused, but we don't want to think about healthcare as happening just within the hospital, but as part of our lives, daily lives, and lifetimes. So we're really excited to get EOIs and presentation submissions. EOIs will close on the 30th of April, so you've got a little bit of time, but don't delay. And we are also really keen to seek partners and sponsors for the event. So if you are interested in partnering, um, if you are interested in becoming a foundation partner, you get complimentary conference tickets as well as access to all of our site visits, events, and stuff like that. So it's an absolutely great opportunity. I hope you all come to Brisbane. I hope Jeff and Brian add that to your travel budget for the year, and calm down as well.
We'll see.
Um,
We'll
I'd love
see.
to visit.
I can't.
I would strongly recommend being there. I think it's a great idea.
Yeah, great. Yeah. So yeah, stay connected and follow us on LinkedIn and subscribe. So if you haven't already realized, you have to follow us. Like you have to subscribe to the newsletter to get all these site visits. Otherwise, you will miss out and be disappointed. So please do that. And we promise we don't spam you with hundreds of emails. So yeah, thank you for that. And if you stay online, you might get if you do stay online for a few minutes, you'll get a request to share your, you know, um, share your screen or whatever, share your video, whatever, if you want to ask any more questions. Thank you. Going to end the recording.